Good afternoon. Good afternoon. Before I start, I would like to thank you for attending this presentation. I haven't expected so many people to be in this room, so it's great to see that you are interested in new trends and new changes in big data landscape. When initially thinking about this presentation about 2 or 3 months ago, I assumed that I will give very technical presentation and I will explain new technologies like containers, Kubernetes, object storage, public or hybrid cloud. But when creating those slides, I decided to change the content a bit and give a bit higher level presentation, because to understand new trends and new changes in big data landscape, we need to know why those new technologies are created, what is the motivation behind it, and what are the politics around, and what we might see in the future. My name is Adam Kawa, and I became a fan of big data technologies in 2010 after implementing my first Hadoop job. I used to work as a data engineer at Spotify, where I was responsible for building and growing one of the largest European Hadoop clusters. I also worked as a data engineer at Truecaller, which is very, very well-known startup in India and Sweden. And I also worked as big data consultant and architect at companies like Allega, Roche, Procter & Gamble, where I was responsible for building their big data infrastructure and implementing big data projects. And in 2014, together with my colleagues, I started a company called GetInData. We have nothing in common with GetInBank. We just focus on implementing big data projects, and this is our passion and what we do each day. To give you more context about why we have so many innovations and so many new projects in big data landscape, I would like to explain that first. So there are two reasons why there are so many innovations. One reason is that there is a big demand for it. Data, databases, analytics, machine learning. All companies would like to be data-driven. They collect, store, and process a lot of data to make decisions better, powered by data, to make their product and services better than competitors. And the second reason is that we have a lot of creators of those big data projects and technologies. And there are different groups of those creators, and they create open source or commercial big data software with many different reasons. So, for example, we have internet giants like Yahoo, Facebook, LinkedIn. They created they created projects like Yahoo, like Hadoop, like Cassandra or Kafka. And initially they created those projects because they needed such a software internally. But later they decided that it would be good to open source those projects because other companies would benefit from that, and also they will build community around those projects, so those projects will get more and more popular. But the original creators of those projects from Yahoo or LinkedIn, they also created own companies called Cloudera, Hortonworks, Confluent, and those vendors decided to implement also big data projects and contribute to them, support them. So another group of companies decided to build open source project and monetize them. Also, those vendors like Confluent, Cloudera data stacks, they need to compete with even bigger vendors like Amazon, that develops Elastic MapReduce, or Google that develops BigQuery or PubSub, because those big vendors like Google, Amazon, or even Microsoft, IBM, Teradata, they also want to enter big data market and create big data technologies. Also, universities create interesting open source big data projects. For example, Spark or Flink were created by PhD students at German and the US universities, and later those projects were donated to Apache Software Foundation, and companies like Databricks or Data Artisans were started. So to summarize, we have a different group of companies like vendors, startups, internet giants that develop big data project with many different purposes. Some of those purposes are to earn money, get market share, get some revenue, but also some of those purposes is to use that software internally for own mobile or web product, or maybe attract engineers and get good branding that will be very helpful for hiring engineers. So this mix of different goals, different companies, different ambitions create very good environment for creating a lot of big data projects. And because of this competition and different needs that company had over time, we saw a lot of big trends in the big data landscape. In 2013, everyone who was doing anything with big data was using Hadoop, and projects from Hadoop ecosystem like Hive, MapReduce, Scoop, Uzi, maybe Flume, and it was great. But in 2014, Spark became very, very popular and very successful, and it provided new way of implementing data processing jobs using in-memory capabilities, using new model, and Spark caused many other big data projects to decline, like Pig, Scalding, Crunch, and MapReduce Paradigm. And also in the meantime, in 2013, a battle for creating the fastest SQL engine for Hadoop started, and many companies entered the game, like Cloudera with Impala, Hortonworks with Tess, MapR with Drill, Facebook with Presto, and even Hadoop, a startup from Boston. But even the fastest SQL query and the fastest Scala code implemented with Spark and with all those in-memory capabilities was not enough for many companies, because some of them needed to process data in real time, because Hive and Spark and SQL engines process data in batches, but some of the companies like Twitter, let's say they required real-time capabilities, and technologies like Kafka and Storm got some tractions, and even Lambda architecture was defined to explain how to implement real-time jobs with Storm and Hadoop clusters. In 2015, based on my observation, Kafka, a technology for streaming data from one place to another, became very, very popular and became the default choice for data ingestion to Hadoop, or data ingestion to real-time engines, or as a data hub for microservices. But in 2016, we see a new trend, which is streaming. This trend was popularized by Google, because Google entered the game and proposed a new computation model called Dataflow. And with this model, we had a single unified way for processing data in batch and streaming manner. So thanks to Google Dataflow, companies stopped using Lambda architecture. Also Google promote a project called Apache Beam, but Apache Beam was just the API. It was not an engine. It was just the set of methods and capabilities that streaming engine should propose. So Apache Flink implemented Beam API. It became a very, very popular streaming engine. And in 2016, this trend continues, and we do more things in streaming fashion, and also cloud becomes more and more popular. So Google and Microsoft, with their cloud services, they start challenging Amazon and provide new features in the cloud, like cloud native projects for AI and machine learning, new types of billings with sub-second billing, and new integrations with open source technologies. So we see in 2017, like new trends becomes very visible, because we not only stream everything with real-time architecture, but we also move more projects to the cloud. But moving projects to the cloud is not that easy, and companies that try to do that, like Spotify, they had a lot of troubles, and it was very time-consuming. So a project called Kubernetes, that was open sourced by Google in 2013, it started to become very popular in 2018, because with Kubernetes we can run our software, also big data software, in other places, like on-premise or in the clouds. So Kubernetes gives you portability. You can run your software and Kubernetes in containers managed by Kubernetes, and later decide where you want to run them, on the cloud or on-premise. And during last 10 years, also companies used many different ways of running big data platforms. Some of them used cloud, most of them used on-premise infrastructures, some of them tried hybrid models, and actually most of the companies started on-premise because they used Hadoop, and Hadoop was designed to run on physical servers. And at that time, the network throughput was very low, like 1 gigabit Ethernet connection, and Hadoop optimized the usage of this limited network throughput by having data locality and having some other useful features, like open source license, so you could just download Hadoop for free and install on commodity software. So companies like Yahoo, Facebook, Twitter, LinkedIn, Allego, ING, they built very successful data infrastructure using open source components on premise. But several companies were implementing their big data platforms on the cloud. For instance, Netflix, and they were using a mix of cloud-specific products like S3 for storage, EMR for processing, but also Spark, Presto, Kafka from open source communities for other pieces of their big data platforms. But they were happy about the cloud because cloud gave them easy installation of those services, so they didn't have to worry for installing servers, connecting them to the network. They were also happy with the security of the cloud and with the elasticity of the resources, because you can request new instances, and in the cloud you get them very quickly. And some of the companies actually tried the cloud, and they were not happy, and they moved back to on-premise. For example, Spotify. When I was joining Spotify, we were just moving from Amazon back to our on-premise installation because the service that Amazon provided to us in 2012, it was in 2012, this service was very expensive. the 60 machines that Spotify bought in their data center cost the same what Spotify paid to Amazon for 3 months of using their services. So running big data on the cloud at that time was many times expensive than running in own infrastructure. And also quality of that service was not that perfect because, for example, we wanted elasticity, so we requested 100 EC2 instances from Amazon. We assumed that we'll get them quickly, but sometimes we were waiting 10 or 20 minutes to get them, and some of them were slow, lagging, didn't work. So the promise was that with the cloud, we would be just focusing on our data engineering, data analytics work, but at the end of the day, we were running into many issues with cloud infrastructure, many low-level issues. So Spotify decided to go back from Amazon to own data center in 2012. However, Spotify changed its mind a few years later. But let's explain that. So after moving to own data center, Spotify infrastructure had been driven by open source projects. So Spotify used Kafka, Cassandra, Hadoop, Storm, and Spotify had one of the largest European installations of those technologies. So Spotify was running those services at very large scale. Spotify was quite happy with them, and Spotify was not interested actually in any other commercial software. However, Google convinced Spotify to move to the cloud because Spotify started noticing that it's very difficult to manage those large installations at this scale, and this scale will grow actually. So it was very helpful for Spotify to move to the cloud because all those difficulties related to managing Hadoop, Kafka, Cassandra will be delegated to Google, and Google will be the administrator of their platform, and Spotify will focus only on building a music application and analyzing its data for better music recommendation, for machine learning, and for analytics. And also Spotify liked the fact that Google provides own services like PubSub, BigQuery, because Spotify assumed that those are great products developed internally by Google and used behind services like Gmail, YouTube, Google Maps, and ads. So it was great, and Spotify accepted the fact that it would be more expensive. But at that time, Spotify optimized for growth, for the success of the music application. So Spotify didn't want it to just save the costs of the infrastructure if they can get great infrastructure. However, there is a second company called Criteo that is very similar to Spotify, because Criteo is also the startup. It has very good engineering culture. Criteo is also early adopter of many open source technologies. And Criteo had even bigger big data installations than Spotify. And Criteo decided that they will not go to the cloud because for their use cases, cloud will be multiple times more expensive. And if they run the software in their data center, they have more control what they actually are running, how it's installed, how it's managed. So this is interesting that two very similar companies made completely different decisions regarding where to run their big data infrastructures. And when currently analyzing the trends and changes in big data landscape, most of them happen in those two areas. One is open source, and second is public cloud. Those are very important areas in big data, and very often they impact each other. So what's going on in the public cloud very often influence what's going on in the open source communities. And I will try to explain that in the next slides. So cloud can be when cloud got very popular during the recent few years, it impacted open source project a lot, because cloud providers implemented own big data technologies that are available for users. So, for example, rather than using Kafka, you can use PubSub from Google or Kinesin from Amazon. Rather than using Hive from open source, you can use BigQuery or Redshift. So Spotify was excited about those technologies and really wanted to use them. But of course, this means that those technologies try to replace the open source ones. So this is good for cloud providers because they have technologies that differentiate them from others. They have technologies that they can offer to the users that they know very well, that they can support very well, that they can provide for a good price. But the side effect is that some open source technologies have hard time because they need to compete with cloud-native technologies developed by cloud providers. And also those technologies increase the vendor lock-in. So if you start using Redshift aggressively as Zalando, let's say, it's difficult to go out. The same if you use BigQuery. And however, there are some open source projects that are too important to ignore, and customers would like to use them. For example, Kafka. So what Amazon did, Amazon just provided own managed service for Kafka. So Amazon simply took Kafka from the open source and integrated with their cloud, and is selling this service to users. So this is quite good for customers because now we can use Kafka. It's not vendor lock-in because we can use the same version of Kafka on premise or in different cloud. But it's not good for Kafka community and Kafka and companies that are behind Kafka, especially Confluent. And similar situation happens to Elasticsearch because Amazon has also managed service for Elasticsearch, and if you use those products from Amazon, the creators of Kafka and Elasticsearch, they don't earn any money because everything goes to Amazon. And also in Google products like Composure or Dataflow, you will see open source project included like Airflow, Jupyter. So to some extent, Google is also doing that, but at least for now, it doesn't hurt much Airflow and Jupyter communities because there are no companies behind them. So Airflow was just created by Airbnb, and for Airbnb, I assume it's fine if someone is just using that software somewhere else and maybe selling that. And so there is even a term for that. It's called strip mining, where someone is taking open source technology, selling that to someone else and not contributing much to open source. Because, for example, Amazon has just one contributor to Kafka, and this contributor is not implementing any code, just creating some bugs and documentation issues. So this is one thing. And also, cloud providers, they create open source project that can be run on-premise, but the real goal of creating those projects is to run them eventually on the cloud. So one is TensorFlow, machine learning framework that you can run on-premise, but Google also and Amazon also provide possibility to run TensorFlow jobs on the cloud in automated, very easy way. And also, cloud providers build their products that are compatible with open source technologies. Like Bigtable is compatible with HBase, Dataflow is compatible with Beam. So thanks to that, if you use HBase or Beam on-premise, you can easily migrate to the cloud. So cloud providers try to make it as easy as possible to migrate to the cloud. So open source projects try to understand the situation and try to do some actions that are good for them too. So, for example, open source project they realize that cloud is very important and people want to use the cloud. So they create own cloud-based product. So you can use Kafka in the cloud by Confluent or Spark on the cloud from Databricks. But in this case, Kafka or Spark is managed. They run as services on the cloud, like Amazon or Google, but they are managed by their original makers, like Confluent and Databricks, and thanks to that, they earn some money. Also, those projects, they follow cloud-first approach, which means that the code is first released to the cloud offering to make sure that it works well on the cloud, where the release cycle is very short, and later it's developed later it's released in on-premise software. But what is really interesting, also companies like Confluent, Mongo, Redis, they change license of some of their projects because if those projects are fully released with Apache license, then everyone can do whatever he or she wants with that product. So, for example, Confluent introduced Confluent Community License, where some of the projects like Schema Registry, Kafka SQL, the license for this project is almost the same as Apache license, but one exclusion is that cloud providers cannot use those projects and sell them. So we see new licenses in open source software that prevents from selling that in the cloud by cloud providers like Amazon. So open source projects try to be compatible with the cloud, try to be easy to run on the cloud, but try to avoid the situation that Amazon or Google eats the whole cake. And one of the projects that make this possible to easily migrate open source project to the cloud is Kubernetes. And Kubernetes is a technology that helps us to manage containers. And in those containers, you can run many different services like Spark, Kafka, Flink. And those containers can run anywhere, on-premise or in the cloud. This can be cloud from Amazon, Google, or Microsoft, everywhere. So Kubernetes is really, really good technology. It's probably one of the most popular open source projects right now with very vibrant community. So having this said, we start seeing following trends in big data landscape. So we have more and more companies that start using the cloud, or at least seriously evaluating the cloud. Companies rather try to avoid vendor lock-in, so they prefer to use open source services like Kafka, Presto, Spark. However, some companies accept vendor lock-in if they think that the proprietary solution is good for them. So, for example, Spotify is using BigQuery a lot, and Zalando is using Redshift, and there are many other examples. Also, open source project, they see the importance of the cloud. They see that the cloud is the future. Maybe cloud is not the majority right now, but in the future it will be growing. So those open source projects try to be cloud compatible, cloud ready, so people can decide if they want to run open source project on premise or in the cloud. And Kubernetes is this magic technology that makes everything possible, that makes easily to move open source project to the cloud. And what happened recently is very important milestone, because during the Google Next a month ago, Google announced a partnership that it signed with 7 open source vendors, and thanks to this partnership, open source project created by the community and created by open source centric vendors, they will be available on the Google Cloud Platform in the same way as cloud native technologies created by Google. So if you want, you can use Kafka on Google Cloud Platform in the same way as you use PubSub. So you have seamless sign-up experience, you have a single billing for those services, and also you get first-line support provided directly from Google. So this is really important step, because it turns this vision of having open source project running on the cloud, it turns that vision into reality. So I'm really impressed, and it's really something that can make a win-win-win model for all parties. So it can be win model for open source, because thanks to this model, open source vendors, they will get some revenue from Google thanks to the fact that users are using their software. Cloud providers, they get more good technologies that are compatible with the cloud, that are used on the cloud by companies. So companies that are afraid of vendor lock-ins, they might still use open source project on top of the cloud and get all benefits of the cloud, like elasticity, scalability, security. And also it's good for customers because they have now option to either choose open source on the cloud or cloud native proprietary solutions developed internally by cloud providers. So in my opinion, or at least this is my hope, that this announcement given by Google a month ago, it will start a new trend in big data landscape, which is open source cloud. So because it's very important, before this announcement was made, I was really wondering how open source project will defend themselves from competitive projects that are cloud native, that are easy to run on the cloud, but maybe now it's going to happen. Of course, this model, this win-win-win model that I mentioned, it has many nuances. It might not work out. It's really a matter how this agreement is made between cloud providers and open source vendors, whether this deal is fair, whether this first line support is efficient, and so on. But hopefully this will happen. And during my abstract of my presentation, I wrote that I will give you example how we at GetInData taking those trends into account and how we implement big data solutions that are future-proof. And I would like to mention one of the projects that we currently do at GetInData. This is a project for a bank from the Netherlands, and we are implementing next generation data analytics platform. So this bank implemented Hadoop cluster in 2014. This was a good success. They were happy with Hadoop, and they implemented many business use cases on top of that. But of course, they know pros and cons of Hadoop running on-premise, and they also see all those recent innovations that happen on the cloud. So the goal of this project is to build a new big data platform that for the time being will be running on-premise, but this platform should be cloud compatible and cloud ready. And for this reason, we use a lot of open source technologies to avoid vendor lock-in, but we use them in a way that is easy to migrate to the cloud. We don't know. Maybe we'll migrate to the cloud in a year, or maybe in a 2 or in 3. We don't know to which cloud it will be. So we need to make this platform very generic. So rather than using HDFS that doesn't have good support on the cloud, we use object storage with Ceph. We use Kubernetes and run our big data services in containers. Currently, we focus mostly on running Spark and Presto and Jupyter on Kubernetes, but we are quite successful in doing that. We implement Flink jobs using Beam API, because with this Beam API, it would be very easy to run later those jobs on the cloud. So we made a lot of architectural decisions to make this platform cloud ready. And probably it will be running in the cloud in future. And we also hope that this would be a very good example how a big company like a bank can prepare for migration to the cloud. First by running it on-premise as it runs today, but be ready to prepare to migrate to the cloud when it's needed in the future. I have a second project that is less interesting, but in this project we use open source technologies like Kafka, Flink, Beam, Docker. The interesting fact is that we developed that on the cloud. It requires some effort, but now this platform runs on premise. But in the future, doing the same would be much easier, because we will have dedicated services like for Kafka on Google, so we wouldn't have to manage Kafka by ourselves. So this was all. I think that we have just 1 minute